Windmill Project, 2010, Senior Physics. As you see here, we have a 20 centimeter blade width. This is a standard windmill. It's hooked up to a DC motor, which is rigged to a power out right here, which one can test incandescent and LED lights. As you see over there is our wind source. It is also hooked up to a much larger version of a DC motor, except this is what we are creating our wind turbulence with. Note this is a closed environment. Between tests, one must let the air current settle. And here's our windmill in action itself with our tester right here, which will give us our voltage readings. And here's test 1. Note this is about 150 centimeters distance. And we have voltage, as you can see. It is peaking at precisely 1.9 volts. It holds fairly steady at this voltage. Whenever a light source is added onto the motor itself at a certain distance, what happens is the power is restricted because the generator must develop enough voltage to power that light source, like an incandescent or an LED light. Done.
As you can see, this was the fan from the first take, but what you can do is you can take these attachments off to alter the fan, as you see here.
As you see here, by altering the fan and taking these attachments off, we have reduced the blade width itself, so less contact from the wind should be touching the blade. So in general, the blade should move slower because our air turbulence is not coming into as much blade contact. So we have such a giant surface area, but now our surface area has decreased on the blade, so our voltage should decrease likewise.
As you'll see in this test here, the voltage should go down from the previous test, which was at 1.9 volts.
As you see here, our voltage has decreased because the blade width itself was brought down to a smaller size. Went from a 1.9 volt to a 1.4, and it's staying pretty constant.
As you see here, the DC motor is creating a charge buildup, which is lighting the incandescent light. When the light is unplugged from its power source, there's no longer an electrical load on the motor. Likewise, the fan spins faster because there are no restrictions.
Blades, 20 centimeters to the center point. Fully balanced. This is the incandescent light bulb up here. It's powered by the DC motor, which when cranked over by the blades, having wind turbulence against them, creates a power source that it goes through these rear terminals right here. And they are transferred, and as you see here, the light, when a sufficient power source is created, will light up as seen in the previous video. Thank you.
Josh, love you!
George Matry!
Dylan the Mo.
Give you up, never gonna let you down, never gonna run around and desert you, never gonna make you